Hey guys, welcome back. This is going to be taking up some homework from last week. It's Unit 1, Handout 2, and just for fun, I'm just going to take up just a few of the questions from the homework, okay? So this is on page 1. It's number 1. We'll just do a few on this page and a few on one of the other pages, and that's it. All right, guys? So this handout, by the way, is basically practice using these formulas, right? The instantaneous is equal to the max times the sine of the angle. E average is equal to E max times 0.637, and E effective is equal to E max times 0.7071. And this one calculates the instantaneous value on the sine wave, so any value anywhere on the sine wave, depending on the angle. And then the average, of course, is the DC voltage, right, guys? Because average is always DC. And effective is going to calculate the AC voltage or RMS voltage. And notice that all three formulas have the max in there, okay? So anytime you have to go from like E instantaneous to E average or E average to E effective, the only way to, well, the best way to do it for you guys is going to be to calculate the max voltage first. We're gonna do a couple like that, so you'll see. Okay, guys? So let's just start with the first one here, just for fun. Calculate the maximum value of voltage on the sine wave if the voltage at 150 degrees is 300 volts. And even though that doesn't say that this voltage is the instantaneous voltage, it must be because it's associated with an angle, okay? The instantaneous voltage will always be associated with some angle on the sine wave. And really what it's asking here, guys, is if I look at the sine wave, pretty ugly, 150 degrees, you know, it's about right here, right? It's saying that voltage there, instantaneous, is 300 volts, and we're trying to calculate the max voltage or peak voltage right there. So we're going to use this formula right here. It's the only one with the instantaneous value in it. E instantaneous is equal to E max times the sine of the angle. And then we're just going to transpose it. E max is going to be E instantaneous over the sine of the angle. All right, guys? And we'll try it out, and then we'll talk about it here for a second. So we're trying to calculate the max. The instantaneous is 300, so E instantaneous is 300, and then the angle is 150, and we should just be able to punch that in there just like that. 300 divided by sine 150, 600 volts. Okay, so it's saying that the peak is 600 if the instantaneous value at 150 degrees happens to be 300. Now whenever I do these, guys, before I move on from them, I always make sure that what we're doing is going to make sense. So the max value on the sine wave is going to be more than any other value anywhere, okay? So you're going to make sure that your max value turned out nice and big, because if you transpose this formula incorrectly and, you know, you might end up with a number here that's, you know, smaller than 150, and you know that that's not correct, okay? And by the way, all these homework assignments have their answers on the back of the sheet, okay, guys? So you can flip to the very back of the assignment, and you can see that the answer for number 1 is 600, and it's right there. And that's going to be for pretty much every homework assignment, okay? They're always going to come with answers, so you'll be able to see it. There's a few exceptions, because in the workbook, there are some handouts in there that we would normally do in class. And so if you try those, you're going to see that there's no answers with them, and that's because normally I would do them together with you, and I'll actually will be doing them together with you as part of the lesson, you know, in a YouTube video, so you don't have to worry about those ones, okay, guys? So that's the first one. We're going to do number 5 here as well, just for fun. Calculate the EMF, and EMF just means voltage, so don't get all wound up about that. It stands for electromotive force, right? So it's another word for voltage. So it's calculate the voltage at 75 degrees if the voltage at 100 degrees is 25 volts. Now, that particular question, guys, it's asking for one instantaneous voltage while it gave you another instantaneous voltage. So I'm just going to draw this sine wave out a little bit bigger than that little crazy one that I drew up there. Here's the sine wave, okay? And what it's saying is that at 75 degrees, so there's 90, there's 75 degrees, it's saying the instantaneous voltage there is equal to, we don't know. That's the one we're calculating, okay? So that's the one at 75, but it's giving you a voltage at 100 degrees, and here's 90 right in the middle, right where it peaks. So at 100 over here, guys, it's saying E instantaneous is equal to 25 volts, okay? Now, the only way to calculate this instantaneous voltage is to have the max voltage, because the formula E instantaneous is equal to E max times the sine of the angle. So if I want to calculate the instantaneous voltage at 75 degrees, I'm going to need the max voltage for this particular waveform. So that's the first thing I'm going to calculate. I'm going to calculate E max, and I'm going to use, here's the formula transposed, okay? And I'm going to use the known value here. The instantaneous voltage is 25 at 100 degrees. So this will allow me to calculate this peak voltage. Let's do that right here for a second, guys. I'll bring in my calculator. 25 divided by sine 100. I should have put the 100 in there, I guess, right? Equals, it's saying the instantaneous, or the peak voltage right there, E max, is 25.38 volts. Okay, so now we know the max for this sine wave. Now I can calculate the instantaneous value at 75 degrees. We'll do it right here. E instantaneous is equal to E max times the sine of the angle. And now we know the max voltage. It's 25.38, and we're trying to figure it out at 75. All right, guys? And so we'll get the trusty calculator going here. Whoop. We'll make some room. I noticed that if I put the calculator in the middle of the screen here, you get my nice light in the as a a lot of glare. So I'm going to try to keep it to the right here. All right, guys? 25.38, it's already in my calculator, times sine 75 equals. Looks like it's going to be 24.52 volts at that instant right there, 75 degrees, okay? And just for fun, that was number 5. Let's verify that we didn't screw that up here, guys. Number 5, 24.5 volts. Perfect. Okay, so that's that one. And, if I'm going too fast, guys, pause the video. If I'm going too slow, speed up the video. Okay, guys? So that's the nice thing about YouTube. You can watch it again. You can pause the video if you want to. You can speed it up, slow it down. Somewhere in the bottom, right about here, guys, on your YouTube screen, you can actually click it and put it at faster speed or a slower speed, so you can actually run these videos at 1.25, 125% speed, or 75% speed, or 50% speed. So you can slow it down and speed it up a little bit too if I'm going too slow or too fast for you. You don't want to speed it up too fast though, because then it sounds like I'm a chipmunk. Okay, number 18 next. Okay, guys, we're still on the same handout. Unit 1, handout 2. Page 3 this time. Calculate the effective EMF again, voltage, when the average value is 30. So I'm going to draw this sine wave so we can see what's going on here. All right, guys? So it wants the effective value, and the effective value, E effective, is going to be E max times 0.7071. It's asking about the AC value or AC voltage on this wave here. Now the only way I'm going to calculate that is if I know E max, okay? And I don't know E max because I only know the average value of voltage. Now, obviously, this thing has been rectified, okay? So they're really asking, if I have full wave rectifier and the output is 30 volts, what was the effective value of the AC before rectification? That's really what they're asking, all right? So the max voltage I can calculate, and once I have the max voltage, I can calculate any voltage I like. So that's the first thing I'm going to calculate, guys. Here's my formula. And I got to transpose it annoyingly, okay? But it's not too hard. All right, those are sevens. And my effective voltage was, I'm messing this up, okay? We have to use this average value of voltage to calculate the max. So let's try that again. E average, E max times 0.637. E max is going to be E average over 0.637. So it's going to be the average value of voltage, 30 over 0.637. And I'm going to do that with my calculator right here. 30 divided by 0.637 equals 47.09. 47.09 volts. That is right here, 47.09 volts. And this is going to be full wave, okay? Because I told you the last time that everything in theory is full wave rectification, okay? And actually, yeah, we'll just leave it at that. All right, guys? So now that I know my max voltage, I can calculate my effective voltage using this formula right here. E. Shouldn't do it off the page, right? Effective. It's going to be E max times 0.7071. Max voltage 47.09. Let's try that. I got my calculator right here. 47.09 times 0.7071. Looks like it's 33.3 volts. And that will be the AC voltage that you started with. Is that right? Should we check that? Where's my answers? What question was this? 18, 33.3 volts. Yep, that is correct. All right, guys, perfect. Okay, guys, so that was question number 18. And we're going to do question number 19 as well. So here it is. Calculate the RMS value of current if the instantaneous value at 75 degrees is 10 amps. So let's see. We'll draw the sine wave again. It wants to know the RMS. RMS is the same as effective. Okay, same thing. It's the AC voltage. So E effective, well, it's E max times 0.7071, but I don't even know E max, I only know an instantaneous value. And it's saying over here at 75 degrees, it's 10 amps. All right, so the first thing we're going to do is calculate I make plenty of mistakes. You're going to figure that out real quick here. Okay, guys? We're going to calculate the max voltage. There's the formula. I have the instantaneous voltage. And the instantaneous, and actually all these are currents. Okay, so never mind all these E's. They are I's. Okay? I instantaneous is 10. The angle is 75. So I max, I'm not going to go back and fix all these E's, okay, but they're all I's. I max is going to be, let's try it, 10 divided by the sine of 75. 10.35 amps, okay? And that is right there, I max, okay? 10.35 amps. Now that I know that, I can calculate the RMS. I effective is going to be I max times 0.7071. All right. I max, whoop, we just figured it out, 10.35, and the 0.7071, 10.35 times 0.7071. All right, guys, 7.32 amps. There's your answer. Now, we're going to check that. I think it'll be all right. Let's see. That was question number 19. 7.32 amps. And it's possible that all this text is too small for you. All right, so this was question 19 right there. Can you see it? Let me know. All right, guys. All right, that's it for today. We're going to carry on another day. Have a good day. Bye-bye.